Nero? One second. If it is visible, 1 second. I want to open the open board. Yes. Document controller. Yes. In the last class, we discussed the controller, what is the meaning of controller, what is the advantage, or why we go for the controller. So, controller means one device or one external device which can be introduced in forward path. Check the diagram, which can be introduced forward path or feedback path in order to change the system performance or in order to get the system performance or in order to get the improved performance. Performance means output. Output is two types, transient output, steady state response. Steady state response or steady state output. So if you want to improve the only transient response, transient means it is having oscillations. If you want to decrease the number of oscillations, then we go for PD controller. In PD controller, we can increase the zeta. If zeta is increasing, zeta equal to 0 means full oscillations. Zeta equal to 1 means critically damping. If zeta greater than 1 means over damping. So if you want to reduce the number of oscillations, you can increase the damping ratio zeta. Then steady state response. How we can improve? Steady state means we can reduce the error. If you reduce the error, then steady state response is good. Loss will be less. If you want to reduce the loss, we go for PI controller. We will see with the small derivation part. Yes. I'll show the diagram, then after that I will check it out. This entire one, this is nothing but a controller. Here I'm using, this is a PD controller, sorry, it is a PI. Okay. Yes, I'm using first, let me start with the PD control because total response is combination of, assume it is the first waveform of that steady state. Let me talk about the transient response. This is the PD controller. So if you remove this one, this is called general standard second order system. Let me introduce one page. Now we'll start with controller, without controller. With controller, without controller. Let me start first without controller. Without controller. How we are going to increase the zeta, we will see by comparing these two. Without control means a general second order system. It is a summing point. General second order, closed loop second order system. Taking the block diagram first. Block diagram. So omega n square divided by s into s plus 2 zeta omega n. Then it is the output C of s. This is input R of s. Assume feedback is negative feedback. That unity. H of s equal to 1. Signal direction is very, very important. Okay, now. So in this case, H of s equal to 1. Let me make a difference between these two. So if it is, this is the standard closed loop transfer function system. This is standard closed loop system. Then open loop transfer function or a block diagram. Open loop transfer function is given by G of s, H of s. In this case, H of s equal to 1. Here it is unity means H of s equal to 1. So G of s means forward path. Whatever the gain in this forward path, we have to consider the entire one. This is a G, H of s 1. So you will get a omega n square divided by s into s plus 2 zeta omega n. So what is the type number? So if you type number is always dealing with the open loop transfer function. Type number. Order means closed loop transfer function. If you want to talk about type means I require open loop transfer function. If you want to talk about order of a system means I want a closed loop transfer function. So in this case, type number means s power j. I gave the explanation also. number of poles at origin. Number of poles at origin. This is the origin. If equate the denominator to 0, S equal to 0. One pole at origin, so its type number is 1. Type 1. If you use controller, the type number is increasing or decreasing. To compare that one, I'm taking the what is the type number. If it is without controller, type number is 1. Then what is the KP? Positional error constant. Formula you know, limit S tends to 0, G of S, H of S. If take that one, limit S tends to 0 and omega n square divided by S into S plus 2 zeta. Anyway, derivation part is not required. If replace S equal to 0, something divided by 0 is infinity. So I got Kp equal to, let me make it as a bracket, within bracket. Kp value I got infinity. If Kp is infinity, what about ESS? Steady state error for step input I'm talking. A by 1 plus Kp. Now A is the step input magnitude, 1 plus infinity. Something divided by infinity means 0. Yes, I got steady state error without controller. Yes, for step input. Steady state error 0. Next one, assume it is a 2. This is the first. Next, I'm going to check third one. K suffix V. Velocity error constant. Formula limit S tends to 0. S into G of S, H of S. Yes, I'm taking that G of S, H of S here. Limit S tends to 0. S into G of S, H of S means this is G of S, H of S. Omega square S into S plus 2 zeta omega n. Yes. Free place S equal to 0. Anyway, but before that one it will get cancelled. You put S equal to 0, this is a 0. Then remaining term is omega n square divided by 2 zeta omega n. Omega n, omega, it gets cancelled. Finally, we get omega n by 2 zeta. Now, fourth one, what is the steady state error? ESS for ramp input. A by KV. KV. A by KV. That equal to A by omega n 2 zeta. Check it out. It is error is not 0. In this case, error is not 0. That means if you assume some input, otherwise because it is a ramp input, it is a step. Assume ramp input as a, assume ramp means passing through the origin. This is a ramp input. If your output is like this, assume it is a steady state output. There is some gap between. It is an input, it is an output. Then this gap is called how much? I got a 2 zeta A divided by omega n. This is the gap. There is a still gap existing by omega n. So even though there is a gap, there is an error. If we use one controller, we can make this error as a 0. We can make this error as a 0 by using PD controller. Sorry, not PD. Yes, PD controller. Last one. So this is the open loop transfer function. Now I'm going to get the closed loop transfer function. Closed loop transfer function already I told. If it is a unity feedback system, closed loop transfer function is numerator divided by numerator plus denominator. This is the numerator. Denominator. If I add that one, you will get a standard second order closed loop transfer function. Omega n square, s square, 2 zeta omega n s plus omega n square. Then what is the order? Let me write here because I'm going to close this one. In this case, what is the order means? Order is always dealing with closed loop transfer function. Highest power of s in the denominator is order. S, it is a second order. This is the data regarding second order system without controller. Now I'm going to put one controller in this forward path. If you put one controller in this forward path, otherwise if you put PD controller in this forward path, what are the elements is going to change? Change means comparing type number is going to change, or error is going to change, or order is going to change, or this omega n, natural frequency is going to change. I will check one by one. Yes, I'm going to use with, second order system with PD controller. With PD controller. I told controller is an external device which can be used in forward path or feedback path or both forward feedback in order to improve the system performance. Yes, let me take second order system with controller. This is input R of S. So I'm going to consider that PD controller. Yeah, I'm going to use that PD controller. This is a second order system. This is second order system. Then it is C of S. Signal direction is important. So already I told, if it is a PD controller, its a transfer function is. If it is a PD controller, if it is a PD controller, its a transfer function is. Check it out. Yes, one second. So it's a transfer function is Kp plus Kd into S. So P means proportional plus a derivative of error signal. PD controller produce an output signal consisting of two parts or two terms. One is proportional to error signal. Other one is proportional to derivative of the error signal. Yes, derivative of error signal proportional to error signal. To remove that proportional constant, I'm using Kp. To remove that proportional constant, Kd. Yes, it is a U of t is output of controller. I told for any controller input is the error signal. Yes, it is an output. E is a input. Output by input is Kp plus Kds. I'm going to take Kp equal to 1, proportional constant equal to 1. I have to take, this is the gain of a PD controller. Gain means it is the block diagram. Input is E of t. Output is U of t. And its transfer function is Kp plus Kd into S. Now I'm going to assume Kp equal to 1. Kp equal to 1. Proportional constant, directly proportional constant is 1 in this problem. So its gain is, let me use a different color. Yes, if you assume Kp equal to 1, then its transfer function is 1 plus Kd into S. Input is error signal, E of t or E of S. It is U of t. This is a general transfer function, second order, omega n square divided by S into S plus 2 zeta omega n. Then assume, because I have to compare with the standard one means I have to take a unity feedback system. Unity feedback system, negative. Unity means H of S equal to 1. Now I'm going to find, because I want to compare the open loop transfer function. For this block diagram, I'm going to find open loop transfer function is given by, again same formula, G of S, H of S. Again I repeat, G of S is nothing but total gain in forward path. This entire one is a forward path. From here to here, it is called forward path. G of S means gain in forward path. That means you have to multiply 1 plus Kd into S with the normal one. That equal to, let me write in next line. 1 plus Kd into S into omega n square. This all the derivations are not important. Simple statement is enough. PD controller is used to improve the transient response or improve the zeta. For that one, I'm giving the derivation part. S plus 2 zeta omega n. Now, what is the type number? Anyway, if you multiply this one, you will get a 1 plus Kd into S omega n square divided by S into S plus 2 zeta omega n. S type number 1. Check it out. Number of zeros at origin. There won't be any change. Even though you are introducing PD controller in forward path, its type number is not changing. S type number equal to 1. Its type number also 1. There is no change in type number. I will ask. Because of if you introduce PD controller in a control system or in a second order control system, then its type number is changing, unchanging, maybe changing, like that I will set multiple choice. Yes, this is a derivation part. Type number is not changing. If I give the statement, it is meaningless as a faculty. That's why I'm giving the derivation part. Yes, first one is clear. Next one, I'm going to find Kp. Kp for this one with the PD control. limit s tends to 0, g of s, h of s. Yes, this is the g of s, h of s. If you put limit s tends to 0, this is anyway 1 plus 0 into omega n square divided by 0. Something by 0 means infinity. Yes, I got here also infinity. Kp. Yes, there is no change in. So for this one, you will get error is a by 1 plus kp, that equal to 0. Yes, it is a 0. It is also 0. Steady state error 0. Steady state error 0. That means there is no change in a steady state response. I'm repeating, even though you are introducing PD controller, it will not affect the steady state error. Check it out. Is there any changes? Yes, it is a 0. It is a 0. Next one, we'll check it out. KV. KV. KV formula limit. Sorry. KV. Not KP. KV. 1 second. Yes. KV equal to limit s tends to 0. S into G of S. H of S. If you put that, anyway, this, if you replace g of s, h of s, this entire one, this s and this s will get cancelled. Otherwise, let me write limit s tends to 0, s into 1 plus kd s omega n square divided by s into s plus 2 zeta omega n. S will get cancelled. If you replace 0, it is 0. Numerator omega n square. Let me write. Numerator omega n square. Denominator is 2 zeta omega n. Check it out. Omega n, it gets cancelled. You will get omega n divided by 2 zeta. Then what about error? Steady state error is a by kv. That equal to a 2 zeta divided by omega n. Check it out. A 2 zeta omega n, A 2 zeta omega n. Yes, steady state error is not changing. That is a 1 mark. If you introduce PD controller in a standard second order system, it will not change. It will not change steady state error. It will not change steady state error. Check it out. This is the without controller. It is with controller. Both will be same answer. That means it is not affect. It will not change. It will not change the steady state error. That means PD control will not change the steady state performance, but it will change the transient performance. We will see. Next, I have to compare closed loop transfer function. Because I have no place here, let me use the next page. Let me use the next page. Yes, on left side, without controller. This is without controller. Last one is closed loop transfer function without controller. Without controller. This is without controller. This is with controller. With PD controller. With PD controller. So closed loop transfer function is given by, I derived this one also, s square plus 2 zeta omega n s plus omega n square. Its order is 2. Order means number of, and otherwise highest power of s in the denominator of closed loop transfer function. If you check the closed loop transfer function of second order system with the PD controller is numerator divided by numerator plus the denominator. If you check this one, what is the numerator? 1 plus kds omega n square. 1 plus kd into s omega n square. Very important. I'm going to conclude this one. Then 1 plus kds omega n square plus denominator. What is the denominator? S into s plus 2 zeta omega n. Otherwise, you can write g of s divided by 1 plus g of s. You will get the same answer. G of s, h of s, you will get the same answer. Closed loop transfer function. So s into s plus 2 zeta omega n. If you solve that one, you will get 1 plus s kd omega n square divided by, I'm going to write in a decreasing order. Highest power is I want s square, multiply s into s square plus 2 zeta omega n into s. Just send this inside, s square plus 2 zeta omega n s plus send this omega n square inside. Yes, omega n square into s is there. I'm writing in a decreasing order. Kd omega n square plus omega n square. Just I'm going to rearrange the denominator term. Numerator I'm not changing. I'm not changing the numerator, omega n square. So I want to comparing this. First one is because it is a s square. Let me write first s square. Then something 2 zeta omega n is multiplied with s means yes, I have to write something into s. This is a s. It is also yes. Make s as a common factor. Then remaining 2 zeta omega n plus kd omega n square. Kd omega n square into s. Yes, I want to compare multiplication of s. Yes, I told if you want zeta value or omega n value, you have to compare the denominator last term and the middle term. Yes, next one is omega n square. Check it out. Last term is omega n square. Let me use a different color to compare. So in order to, if you want to get the zeta value, just compare the denominator only. I'm not going to compare the numerator. Yes, what about the last term? Without controller, last term is omega n square, last term is omega n square. Yes, no change in, no, let me write, yes, no change in omega, natural frequency, first point. Second point, what about the multiplication of this one? 2 zeta omega n. So here also 2 zeta is there. To compare these two, I'm going to use 2 zeta dash. 2 zeta dash. I'm going to compare the multiplication of s without controller with controller. The multiplication of s is 2 zeta omega n. So to make the difference between this zeta, I'm using 2 zeta dash omega n. Yes, this is 2 zeta dash omega n. That equal to multiplication of s is this entire one. Multiplication of s is this entire one. 2 zeta omega n plus k suffix d omega n square. Make omega n gets cancelled. Then take this 2 also. Otherwise, send this 2 omega n to the left side. Remaining one is zeta dash equal to 2 will gets cancelled. Omega will gets cancelled. Omega. Otherwise, yes, check it out. Otherwise, let me write one more step. 2 zeta omega n plus kd omega n square divided by 2 omega n. If write separate, 2 gets cancelled, omega gets cancelled, remaining one is zeta plus again kd omega n square by 2 omega n. Omega n gets cancelled, then kd omega n by 2. Check it out. Without controller, its damping is zeta. Without control, damping is zeta or zeta dash. Check it. Zeta dash equal to zeta plus something means damping ratio is increased. It is a plus something. Anyway, natural frequency is a positive. Kd, proportional constant is a positive by 2. This entire one is at least it is greater than 0.1. So zeta plus something means zeta value increased. Previous one is zeta. Now what about if you use a PD controller? Zeta plus something means zeta value is increased. That's why if zeta is increased, I told if zeta is increasing, number of oscillations in a system will decrease. Zeta increase, MP, maximum peak overshoot is going to decrease. First one. And the second one, if zeta is increasing, peak time is going to decrease. It will take a very less time to reach the input. Peak time, maximum time is going to decrease when zeta is increasing. I given the last class derivation part also or explanation part also. Third one, settling time also decreasing. Because settling time I given formula Ts equal to 4 by zeta omega n. If zeta increasing, settling time decreasing. And Tp is pi by omega n into square root of 1 minus zeta square. It is increasing, it is decreasing. Then fourth one, what is the fourth one? MP, Tp, settling time, which is going to decrease. will check otherwise give the relation between TP is decreasing, TS is decreasing, MP is decreasing. These three will play the major role in transient response. Yes or no? These three will play the major role in transient response. If these all parameters are decreasing, then transient response is going to improve. Improve means within short interval of time. That means, assume this is a without controller. For example, without controller, assume input is a step input. Let me use a different color. Draw the without controller, assume it is a waveform. Assume it is the waveform. This is the cap. Yes. How many oscillations? It is a 1, 2, 3, 4 oscillations there. Assume if you use the controller, with controller means I'm using PD controller. With the PD controller, assume it is a step input. It may take, that's all, 1, 2, 3, 4 oscillations. If you use PD controller 1, 2, 3, after that it is going to constant. Otherwise, sometimes it may be E itself will start positive, negative, and then it is going to move like this. But there won't be any change in. If it is a ESS, it is also ESS because it will not affect the steady state response. That is the points. Let me give theory part about these all are the derivations now. Yes.